Good day, everyone, and welcome to another edition of Are the Expressions Equivalent? That's right, today we're going to be talking about how to determine whether two expressions are in fact equivalent. Now, remember the word equivalent simply means that they're the same value, but they look different. They're written different. So we can actually use the properties of equality to rewrite these to see if they'll look the same. So let's dive right into it. For this first expression, I can use the distributive property. 2 times x is 2x. Bring down our subtraction sign, and then 2 times y is in fact 2y. And look at there. It would appear as though they are equivalent expressions because just by using the distributive property, I have the same thing. So yes, there's your fireworks. They are equivalent. But let's see if we can do similar things with similar expressions. Looky there. We have once again 2 expressions, and we're checking to see if they are the same value, just written differently. Well, I can actually use the distributive property once again, so let's do it. We have 4 times x is going to be 4x. Bring our plus sign down, and then 4 times y is 4y. And looky there. We have 4x plus 4y is the same as 4y plus 4x. Now, I know what you're saying. You're like, now, wait a second. Now, that doesn't look exactly the same thing. But remember, with addition, you can actually rearrange stuff. So even though we got a 4x here and a 4y there, and it's like the opposite here and the opposite there, because of the commutative property of addition, we can actually change the order that we add things. So I can leave this the same. We'll say this is 4x plus 4y, and just rearrange this. So this is 4x plus 4y. Now they look exactly the same. So yes, they are equivalent. All right, let's do some more examples just to keep the momentum going, shall we? All right, so let's do that. First of all, let's look at each individual expression. We have 4p plus 3c. And that literally looks nothing like this thing right here. But I can see I can use the distributive property over addition. So let's go ahead and do that and see if they do in fact look alike. So I'm going to distribute the 2. And 2 times 2p is going to be 4p. 2p? I shouldn't say it that way. To be or not to be. Oh boy. And then I'm going to bring the plus sign down. And then I'm going to do 2 times c. 2 times c is simply 2c. And now that I use the distributive property, does that look the same as this one right here? 3c, and then I drop down my 4p. Well, it doesn't look the same. I mean, we got a 4p over here, and we got a 4p over there, and we could switch them around, but I mean, unfortunately, this is different, and this is different. 3c and 2c are not the same. They're never going to be the same. So these are not equivalent. There's that little face that's like, guess they're not equivalent. All right, now we're going to move on to this next one. We'll give it a try. Okay, now once again, 2 expressions. And one of them we can actually use the distributive property. The one on the right, let's go ahead and distribute the 7. I guess technically we could take out a factor, but for right now, let's do it the easy way. We got 7 times p is going to be 7p. We'll drop down our subtraction sign, and 7 times 3q is going to be 21q. Now, is that the same as this expression over here? Are they equivalent? Yeah. I mean, all we had to do was distribute the 7, and yes, they are equivalent expressions. Now they're written equal because they look exactly the same. Okay, so let's go ahead and try another one. Let's try another one. let's try another one. Let's try another one right now. How about this right here? Okay. Once again, two expressions. I can easily use the distributive property to see if these are equivalent. So let's dive right into it. 4 times 2a is going to be 8a. Then I bring the subtraction sign down, and then 4 times 3v is going to be 12v. And there we have it. Is that equal to 8a plus 6v? Well, as you can see, it's not. 12v is not going to be the same as 6v, so those are not equivalent. Not equivalent. And there's the disappointed face. Wish they were equivalent, but I guess they're not. He's got like his hands on his hips. He's like, they need to be equivalent. All right, next problem. Enough of the artwork. Okay, how about this one right here? What we've got is we got this expression, includes a -1, and this expression, which also includes a -1. They look a bit different. Let's see if we can get them to look the same by using the distributive property. So, 8 times 3 is going to be 24x. I should say 8 times 3x is 24x. Bring our plus sign down. And then 8 times c is going to be 8c. And now I can bring down my -1. Now, is that the same as 8c plus 24x? Whoops, I'm struggling over here. 24x minus 1. Well, it was really close, but because of the commutative property of addition, I can actually reorder these so it looks exactly the same. So let's go ahead and leave this one on the left side exactly the same. So we've got 24x plus 8c minus 1. And let's just reorder this. Let's put our 24x plus 8c so it mirrors exactly what we're seeing on the left side. And you can see that, yes, they are equivalent. Here's a happy face because we're able to get them to look the same. So, equivalent. All right, let's keep it going. We're having a good time. We're doing mathematics. We're checking to see if expressions are in fact equivalent. Let's see if we have any luck with this one. Now, once again, two expressions looking very different. But what if I use the distributive property? It looks like I can distribute on both sides. So let's do this. So I know that 3 times 2 is going to be 6x. So 3 times 2x is 6x. Bring our plus sign down. And 3 times 11 is going to be 33, right? Now, is that the same as this guy when we do it? Distribute the 2. 2 times 15 is going to be 30. Oh, it's not looking good. Bring our plus sign down. And then 2 times 3x is going to be 6x. Well, the 6x's are the same, but sadly, 33 is not the same as 30. It will never be the same, so those expressions are not equivalent. And once again, here's a angry face because he really wanted it. He's like, why? All right, next problem. We'll see if we can get angry face to be happy face because we're now going to try another set of expressions. We have this big long one right there and this one sort of long one right there. Kind of squished because I ran out of room. But let's see if they're in fact equivalent. Okay, so let's see. What if I do a little bit of combining here? If I got 2 x's and I combine it with 2 more x's, how many x's do I have? Well, yeah, I got 4 x's. So we'll put our 4x right there. I don't have any other c's to combine with this c. So let's go ahead and drop that down right here. So I'm going to have a plus 2c. And I don't really have any other, integers. to combine with that, so we'll just drop down our plus 6. Boom. Okay, now, is that the same as this guy right here once we do the distributive property? 3 times 2 is going to be 6. Oh, it's looking good so far. 2 times C, I do little arrow things, 2 times C is going to be 2C. Oh, we're getting good. And then 2 times 2x is going to be 4x. And I'm just dropping down the signs that we saw before. So are these expressions equivalent? 4x plus 2c plus 6. 4x plus 2c plus 6. Yes, they're equivalent. Yay, there's a happy guy. That's not a smiley enough face. I got to work on my smiley faces, you guys. Yay. And there's the excitement coming out of his head. All right, let's keep it going. What about this guy right here? What we have here is we have just a couple more maybe. We got 3e plus 7 minus e. So we have this one right here versus this one right there. Are they equivalent? Well, let's go ahead and combine our like terms. Remember, terms are separated by addition and subtraction signs. So we have 3e, and if I get rid of one of the e's, how many e's do I have left? Well, I got 2 e's left. And then we'll add 7 to that. Now, is that equal to what happens over here? I have 2 e's. I combine them with another 2 e's. I now have 4 e's. And then if I have a positive 10 and I subtract 3 from that positive 10, I'm left only with 7. Now, unfortunately, you can see they are not equivalent. Not equivalent. This is my sad Einstein. Hold up. I'm struggling. Okay, wait. Sad Einstein coming up. Oh no, they're not equivalent. This is so not rational. It is not logical. Am I mixing up Einstein with Spock? All right, let's do one more set of expressions to see if they are in fact equivalent. This expression here and that expression there. Now, let's dive right into it. By combining like terms, I have 5 C's. I go to the store and get 4 more C's. How many C's do I have? I now have 9 C's. And then I can simply drop down the plus 2 because there's nothing else to combine that with. Now, is that the same of what's going on over there? I don't know. I see I can use the distributive property right here, so let's do that. First of all, I'm going to bring this down. So we got our 5c plus 2 times 2c is going to be 4c. And then bring down our plus sign. 2 times 1 is going to be 2. Now, they're not quite looking equivalent yet, but I can actually combine 5c to 4c. And if I combine 5c to 4c, I end up with 9c. And then I can just drop down that plus 2 and, well, look at there. 9c plus 2 is, in fact, equal to 9c plus 2. So, yes, they are equivalent. Da, 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 da. That's my fireworks, guys. And they all lived mathematically ever after. Like and subscribe. And good luck.